So now you should hear me. Okay, so 25 is okay, right?
Yeah.
Okay, so again, as usual, I'd like to say hello to you in these very nice rooms here in the city center. As you also probably have spotted, this is just a representative office, right? So we have here the conference facilities. My institute, Fraunhofer Fokus, is located some 8 kilometers from here, much closer to the Technical University, where we also have a nice conference center, but more importantly, we also have laboratories where we really play with the technology. When I'm saying playing, we have coined the term of playgrounds instead of test beds, where we want to explore new technologies. And yeah, we have a long history. As you know, we did this whole iptel.org thing long ago, and since then we moved into IP multimedia subsystems, into evolved packet cores, and nowadays we are right in the 5G universe. And I want to explore with you or tell you a little bit more what we are doing in this field of 5G, which is a hot topic. And particularly, you may know that here in Germany we are trying to become kind of pioneers, because the most important asset in a 5G environment is the ownership of the frequencies in order to roll out this technology. So Germany takes a very specific approach, because some quarter of the available frequencies for 5G will be given to local network providers. Local network providers means here everyone who has some ground, being it a university, being it an enterprise, being it some company, could apply for the frequencies to be used in this specific area. And this makes it very, very interesting, and this exactly is the field of where we are jumping in with our toolkits in order to show how technology, 5G technology, could fulfill the promises. So, as usual, I have a big pile of slides with me, and I will jump across many of those. The presentation I will give you later on so that you can digest a little bit in more detail. So, in principle, I just want to motivate a little bit what, from my perspective, is 5G. There's a lot of buzzwords out there, and let's say everyone is having its own views. Important is that 5G is a flexible technology which could adapt to different application domains, and particularly this is quite important to understand. There is no single 5G technology which fits all. It is a technology toolkit which has to be customized. And particularly these days, we believe, and many others as well, industry networks will become quite fundamental, and there is hopefully the big money. And last but not least, I want to tell you a little bit what we are doing in this context as some pioneers in Europe and across the world with our toolkits and testbeds. So in principle, I just looked at the recent Gartner hype cycle. 5G is still a very, very hot topic, and there's still some way to go. When we look on the main part of this slide, the different eras should illustrate the impacting technologies which will coin finally 5G. And it is indeed also a new radio access network technology emerging. But last but not least, a key attribute of 5G is that it should integrate also existing access network technologies. And this includes, of course, LTE, but also satellite networks, fixed networks, and others. More important, and most important in my understanding, is that 5G is really a software-based network architecture for the first time, because here all innovations we have seen in IT in the past decade will be explored, being it network function virtualization, being it the whole software-defined networking principles, so the control and user plane splits, and last but not least, also the new notion of edge computing, which indeed is the prerequisite for low latency communication, which very often is attributed with 5G. Also very important on this slide to stress is that multimedia communications, to some extent, is not the most important communication. It will be machine-to-machine communication. It will be the Internet of Things, which will hopefully generate the big revenues in the future. And this is why 5G should be seen as really an infrastructure coming up for the digital transformation of society where everything and everyone is interconnected. So there is an old picture which has been drawn in the 5G Infrastructure Association initiative from the European Commission, which somehow illustrates a small part of a future city and illustrating the different application domains, not exclusively all, but some where 5G technology may make a bigger change in the future, being it in e-health and the interconnectivity of devices in a hospital, but also in ambulances driving around, being it smart vehicles. And of course, these days we are talking about the autonomously driving car, but we also will see applications which will be integrated in scooters, in bikes, and other vehicles coming up in the future. We, of course, see some kind of entertainment, and multimedia, of course, is still part of it, but it is also energy networks, and most importantly, the factories of the future, which will take advantage of this technology. And as we can imagine, most of the objects which we are seeing on this slide are devices. And this is what is an important aspect. There, of course, are lots of research done in order to understand the requirements of these different application domains. Because, let's say, there is a difference in how many devices, how is the mobility of these devices, how is the bandwidth need, how is the latency need in communication. This is quite important to understand, and there are big differences, but there are also some kind of commonalities. In order to understand the 5G design principles, it's good to take a look what NGNM has published long ago in the white paper. So this was published in the 2015 time range or 2014 time range, as you can see here. And the most important point I want to stress here is that there is this notion of building blocks which could be somehow integrated, control plane functions, user plane functions, radio access network technologies, and so on. So virtual capabilities which will be placed on different data centers. And according to a specific configuration, we can support operator services, so classical telco services, but also enterprise networks and different vertical domain customized network environments. And of course, all this taking advantage of the newest technologies. So this triangle, which is shown here, is a famous one because it shows the different capabilities of, let's say, in communications. So let's call it the most extreme edge, or let's say the most extreme differentiations, because here we talk about really massive numbers of end systems, which not necessarily have to exchange a lot of data, but small data, and it's the sheer mass of the devices which need to be supported. On the right-hand side, we have this ultra-reliable communication and low-latency communication. Some people argue that these are two different sets of capabilities, but it is currently combined. So here, we particularly focus on the low-latency, real-time capabilities in communications. Depending on what type of application we talk about, the data might be more or less, but this is robot control, factory control, control of cars, and other things. And last but not least, the enhanced mobile broadband is the massive amount of data which should be transported. Sometimes we talk about data showers we may experience in airports in order to download mediatheks or whatever is important for us. So obviously, these different communication capabilities deserve different infrastructures which are optimized for supporting these different parts of this triangle. And then to the next slide, which somehow should illustrate how we can imagine how this could look like, depending on whether you want to support a kind of multimedia service or a streaming service or maybe an IoT control service in the distributed infrastructure, you have to place your supporting network capabilities, indeed functionalities which may support mobility management, but honestly, if you have not moving sensors in a factory, you don't need mobility management, as an example. If you know these sensors right away and they are fixed, connected to the infrastructure, you also can avoid authentication, for example. So these are just some stupid, easy examples that a network configuration is quite important to support the different use case scenarios which I just mentioned. On the other hand, what is important here on this slide is to understand that we have the notion of edge computing. So this means we have data centers which are somehow closer to the point of communication control. So what I want to say is if we want to achieve a 1 millisecond delay, there is Einstein and the speed of light, which somehow is limiting the distribution of control capabilities. So this means if you consider some kind of processing and then you look at the distance, probably 50 kilometers is a realistic distance for an edge computing data center in order to support a millisecond of delay for controlling some robot arm, as an example. But last but not least, also on mentioning on the right-hand side on this slide, we see new end systems which are also programmable. So it's not just a smartphone doing voice over IP or video streaming. It is devices which need dynamically to be configured in order to be attached to a network and to fulfill specific jobs. So the machinery in a factory plant will be dynamically programmed in the future in order to build in a very flexible way new products. So this means we just have to understand that we look at a configurable end system which could be programmed according to specific needs. So let's look on the timeline for 5G. So first of all, this is a very big challenge to implement such an infrastructure because you have seen it is driven not, in the past we had this stage 3 standardization. We know what kind of service we have, so we did the service descriptions, specified the functionalities, and in a third step, standardized the protocol. So here in this context, it's much different because here we have some vague use cases, some vague interactions, machines communicating with each other based on different protocols, being it UPC-UA or 1M2M protocols. And on the other hand, we have different access network technologies to be incorporated, and so on and so on. So this means the official rollout for Europe should be 2020, because by then the frequencies are given to the different operators. The auctions are currently going on. In Germany, we probably reach the 6 billion euros, and this is quite a lot of money for just the frequencies. Also, very important to understand is that we need to set up a lot of base stations because the frequency range in the 3.5 to 3.8 gigahertz spectrum, of course, deserves many more base stations compared to LTE as an example. So in 2020, we plan for these rollouts, but then the question is, what type of products can we expect? And it is worth to take a look at the standardization in this context. So we currently see that 3GPP, of course, is driving 5G standardization, and Release 15 has been finalized last year, and this will be the base for the first products which we see. Release 16 standardization is going on, as you can see here on this slide. And we will see that by the end of 2019, those standards hopefully should be finalized. And this means that we are not seeing any valid products before 2020. So now the challenging part is I don't have the time to look into the details. We have to understand that Release 15 basically just looked at an evolution of LTE, and particularly focused on multimedia extensions. So when we talk about low latency communication, which to a large extent is considered as the key enabler for future applications, a really new enablement for new applications, this type of standardization is only partially happening in Release 16 and will be majorly covered by Release 17. So this means that products supporting low latency communication to a large extent will not be in the market before 2022. Yeah. So this means whenever people talk about we will roll out the first 5G network, look what is finally behind. Very likely it is, of course, more frequency ranges or more bandwidth for the end users for multimedia applications. When you look at the current end systems becoming available, we see some strange Huawei and other phones, you know, these foldable things which probably don't work in the first generation of phones. And these are multimedia devices. So the first question for me is, will you and will your kids eventually pay more for having more bandwidth and more speed? So how unhappy you are with LTE at this point in time. Very often in the current auctions around Europe, there is the mentioning of please fill the white spots, so provide full coverage for the nation. 5G is not the technology to do this because it's a super duper high-speed technology. So long story short, meaning and message, I personally doubt that 5G will generate much revenues in the first years, particularly when network operators have to roll out this infrastructure across a country with products which are, I would call them, in infancy. So this is the reason why I personally think the money in 5G is in special networks, is in networks which will support low latency. So we just learned, okay, low latency support will happen much, much later. So particularly the problem is a rollout of this infrastructure across a country. So what is the solution? Roll out this technology in limited locations. Maybe go for prototypes, early stage. You may just need 1 or 2 base stations in a factory plant. And what you need besides the base stations, of course, the end systems, but you also need a core network. And this is what I want to talk about. So just to understand what was the core network evolution, and obviously you know that me and my team, we are working on core networks since a while. So we created the open EPC technology, which we have shifted to a spin-off company, Core Network Dynamics. So we are very happy Core Network Dynamics has been sold last year. And the interesting part is that the company was bought by not a network operator, but by a big company which is building IoT infrastructures and IoT networks. So long story short, sometimes you see that the market is highly dynamic. But coming back, we continued our research developing a 5G core according to the standards. the open 5G core. And of course, we have seen this evolution, and the evolution is particularly in the context of network virtualization, control user plane split, flexible access network integration, which also means flexible authentication capabilities need to be supported. And last but not least, taking into account that there is a notion of edge computing, which allows to separate the deployment of core network functionalities, even leading to the possibility to deploy a whole core network just in an edge, and then consider this edge network in a factory a standalone network. So 5G is a programmable network infrastructure allowing different access networks to be interconnected. I don't drill down into the components of the core network, but this is just for illustration purposes that it is an evolution of the EPC, but particularly takes into account the support of network slicing and edge computing and flexible access network integration. Edge computing, however, is very important because when we try to understand what are the options for exploiting edge-based networks or edge computing, then we can say there might be completely isolated networks, which might be on a drilling platform in the ocean, which might be on a big ship, which might be a factory, which might be a hospital, or so on. Sometimes the hospital is probably not independent, because the hospital has some needs for local communication, but is probably connected to a backend. Now the question is, how is this interconnection of the backend handled? So do you need a permanent interconnectivity, or maybe a time-to-time connectivity, and so on and so on. So we looked into this in more detail. We identified potential deployment options to place the functionalities of a core network as partially in the edge up to a full network in the edge able to interwork. So understanding this and understanding that it is possible to build up a local 5G network with whatever you have as access network technology and a 5G core, the question is this a valid option in contrast to network slicing? And basically, this is what currently network operators are pushing out. They say 5G is a very flexible, configurable network infrastructure, and they roll it out throughout Germany. And thanks to software configuration, a network slice could be optimized for machine-to-machine communication or could be optimized for multimedia communication. So this means network slicing here means that we will build up virtualized networks for different virtualized network operators, which might be enterprises. The question, however, is who needs full distribution across a country versus if industry is quite important and manufacturing and automation in factories becomes very important and 5G is an enabling technology, the factories are local. So we can build local 5G networks. And basically, this is what is currently in the mind of many people in the industry. So there have been lots of analytics in the sense of what are potential application domains. So here you see energy and utilities, manufacturing, public safety, healthcare, and so on. And the interesting part is that manufacturing is a very important area. It is not the biggest market, but it is nearly the biggest market. But the willingness of the industry to invest in setting up local networks is very high. There's a high pressure to have a network infrastructure enabling the revolution of the industry, of the fourth industrial revolution. And the idea to illustrate this to you, we are departing from these, let's say, production lines to a very flexible factory hall where robots are dynamically configured in order to build a new car, a new scooter, or whatever. And these devices have to talk to each other in a very dynamic way. And so there is a lot of research and, let's say, assessment of what is needed. And I want to point you to what is called 5G ASEA. So similar to the 5G AA, which is the Automotive Association, which produces wakey results, I would say, at this point in time. 5G ASEA is the association for the manufacturing industry. industry-driven, and they looked at the requirements, what they need, and they did a lot of comparisons whether network slicing offered by the network operator or private networks are better for providing the low latency and reliable communications. And you see here that particularly the result is local networks are better. So in this context, we can say there is also a clear business case for local networks because you know what needs to be supported in terms of communication. You probably have to invest in one or maybe a few base stations. You need your own small core network. You can go for innovative extended core networks for this specific application use case. So you can calculate the costs and the operational costs, which is more difficult for a rollout throughout the country. But there was a missing piece, and the missing piece is now here. So in Germany, 1/4 of the frequencies is not given to network operators. So the 3.7 to 3.8 gigahertz spectrum is assigned. So if you are in Germany and you have a building on the ground, like we at Fokus, we can apply to make use of this frequency range at Bundesnetzagentur, and we get it. There is just a small fee, administration fee. The only point is we have to argue why we need it, and we have to use it after 1 year. So the challenge is the proper planning of this kind of infrastructure. If we do use the frequencies, we can keep it for 10 years. So that's the interesting part for factories. And this is what is going on in Germany. So just 2 more minutes on what we are doing. So as said, we did this voice over IP, IMS, EPC thing. Now we are very strong in the industrial IoT and 5G domain with toolkits and testbeds at Fokus. The Open 5G Core Release 4 is implementing the 3GPP standards to a large extent. If you would visit us at Fokus, you can just come and see what we call the 5G wall. So the 5G wall is similar to the Open EPC wall, illustrating what capabilities, what functional entities are existing and how do they communicate for specific application needs. In reality, it shows this could be a completely distributed network environment, but we can also bring the whole thing down to one small network, let's say database, or not database, data center, which in the worst case could even be an Arduino board mounted to a small cell. So the playground makes use of this technology and is customized to specific use cases. So we have a smart parking automotive lab in our basement. We have some manufacturing laboratory. We have some multimedia work going on. But most important in these days, and this is why I have to escape right away after this talk, is we are building up local factory networks. Smart factories is the new buzzword here in Germany. And in principle, you see that in the shop floor, in the factory, the devices are interconnected with a local 5G network, being it mobile or fixed. And there is the dynamic programming of these devices, either in the devices or in the edge node. Virtual PLCs, process logic controllers, is the big buzzword, are quite important for this. And basically, we are currently enabling quite some Fraunhofer institutes. You know, Fraunhofer is very strong in manufacturing. We have some institutes which are working very closely with the manufacturing industry, and sometimes they lack a little bit the communication capabilities. So we provide those communication capabilities, and this is why we are providing our 5G network expertise to these smart factories which are built in Germany. One example, what we have done, the biggest show for the manufacturing industry is Hannover Messe. So this was 4 weeks ago in Hannover, obviously. And what we have done, there is a new shiny star company in Germany. Note the name, German Edge Cloud. So this is a company which is privately owned by a big industrial person, Mr. Loh. And in fact, this German edge cloud is planning to roll out lots of edge clouds in Germany. We are a strategic partner. They are partnering with a lot of Fraunhofer institutes. But what we did at Hannover Fair, we have connected small cells in the 60 gigahertz frequency with our 5G core. And we have transported virtual reality information. So you had some glasses, some joysticks. And with the joysticks, you had to control this robot and the arms of the robot, and there were some eyes, some camera systems, and basically we did the remote control of these arms. The latency in this experiment was 4 milliseconds. And this was quite cool. I can tell you there's a lot of media reports about this. There was a 5G hall some meters away from us. They managed 10 milliseconds with some carrier-grade equipment. Yeah? So we were really some guys who really showed, and you know, Fokus motto is demo or die. So, and in this regard, we want to show that technology. Also, of course, we want to show what does not work, and this is also a very important point. Last point, but now the question is, you have a factory. Maybe you have something else. This something else may move. A moving 5G island. Maybe you need to connect it to some backhaul. And the satellite is quite important for this. So at Fuseko Forum, our big show during the year, we have worked together with Bundeswehr-Universität because they have very nice satellite access. And we mounted to this Bundeswehr van a local 5G network, and the backhaul was a satellite network. For some use cases, this is quite important when you want to have fast local connectivity in areas where, for instance, you need emergency support, and then you have at least some backhaul where this information could be transported to someone else. Of course, not low latency communication, but at least massive bandwidth is available. So these are just two examples what we are doing. We are also providing for the European Space Agency the German 5G satellite integration testbed. We do a lot of deployments in Asia and in Europe, and we are considered a very important testbed in the European 5G trial projects. So I think that's it from my point of view to tell you that we do something which hopefully has some sustainability, and I hope that the passion I have for this 5G technology somehow also can capture you. I'm happy to talk more on this, probably not today, but my contact details are here. And if you are in Berlin, close to the Berlin airport, Tegel, then Fokus is not too far away and you can see all this. Thanks for your attention.
Thank you, Thomas. Thank you. I hope you have time for some couple of questions because it was I was coming to James, is always asking a question about it. But just not to push it, do you have dates for the Fuseko and 5G week?
Yeah, of course.
So everyone knows it before we start with the question.
As usual, we have the Fuseko Forum in November. Yeah? So the weather is even worse than now. So no boat trip. The cool thing is we go to the TV tower you can see here, the Fernsehturm. This is our social event, so we let it burn in this evening. But more important is you will see network operators and you will see the industry talking about 5G. And the question is, how ready is 5G for rollouts?
Okay, so note the dates and you can see the demos at their location.
Exactly, nice. So it's November 7th and 8th.
Yeah, Thomas, great, exciting stuff you're doing here, and great news to hear about the German spectrum bits and pieces. I'm going to talk a little bit later, and unfortunately you're going to be diving off, about what's happening in UK. In UK, we've actually got not one, but 3 bands becoming available as shared access. With all of the privately owned stuff that you're doing, have you done anything looking at providing reverse Mvno services to allow MNO users to roam onto private networks? Are you doing anything in that area?
It's an interesting question you are raising, and indeed we are exactly working on this. So to give you an example, and indeed the demo which we have shown at Hannover Fair was so inspiring that Mr. Höttges from Deutsche Telekom was really amazed to see what we have done. And basically he also said, Deutsche Telekom is probably far behind the plannings and rollouts and so on. And of course, network operators are interested to exploit how they can get into this business. And even yesterday I was quite busy before the boat trip talking to some companies with which we are building those local networks. And now there are two questions. Either could the network operator also serve the connectivity of this factory, not via slicing? And the second scenario is exactly opening up the infrastructure and the private frequency for the network operators to have an additional network slice. Because first of all, the highest priority in this factory place is machine-to-machine communication, high, secure, isolated network. However, you also have a multimedia part, and maybe this is also a playground for the SIP community, because in the end you need some kind of local customized IMS infrastructure for supporting and maybe even for virtual and augmented reality applications. But the people also locally may want to do phone calls, video calls, and so on. So now the question is this kind of multimedia communication slice an own slice? Is this a local network operator which is allowed to do it locally? Or is it something where you have interconnectivity with the network operator and you may even consider roaming agreements? So we are in, I would say, honestly, in infancy, because this is highly political stuff. Yeah? But I'm more than happy to be in contact with you, exchange some ideas. From a technical point of view, we are now playing, you have seen the slide with the different configurations of the core network and the interactions. So we are now playing around what might be options to interconnect with network operators to facilitate this. Yeah, let's exchange business cards because I have to run to Focus, unfortunately. But you can exchange the presentations. Yeah.
Hi. The question is also on the factory network. If you have your standalone factory network, would that involve that you have to deploy your own enhanced packet core also? Or would there be some kind of business model, as everything is SDN, that you just take an instance from a national provider, for example?
Honestly, acoustically, I didn't get your question. So can you repeat what you're looking exactly?
If you deploy, if you deploy 5G in a factory network, yeah, first of all, you have the RAN component, which is for me fairly clear. The question is more what to do with enhanced packet core. Do you have to deploy your own enhanced packet core infrastructure, or would it be possible in some way or another that you just take an instance from a national operator, for example?
Okay, good question. My hope was that I already explained this somehow. I personally would say there is a need identified for a local 5G, you call it enhanced packet core. Yeah? Because anything else is what Deutsche Telekom, Vodafone, and eventually Telefonica may announce as campus networks. So a campus network is considered a local network slice offered by network operators. The big question, unfortunately, up to today is who will be the provider of this technology? When you talk to the Nokia, Ericssons, and Huawei's, they have large-scale 5G cores. They are unable to packetize it down. Yeah? That's the big challenge for these guys, and this is why they talk to us as well. But the other point is there's a business model in mind of network operators. The big problem is that they currently, at this point in time, go for some trials, but they cannot even say how much does it cost and how is the quality of service. Because what I didn't mention, in one of the slides you will see it, the reliability needed in a factory is 1 digit more. There's 1 9 more than in classical telco networks. Because in a factory environment, they don't say, hey, the network is down for 30 minutes per year, because this might happen in a row. For them, a problem is if the network is down for 30 seconds, because then a whole production line is ruined. Yeah? So, and network operators are, at this point in time, because it's a completely new domain, are reluctant to say, hey, we are offering this quality of service. Yeah? So no one currently can do this. Probably a small startup can say, hey, I give it a try, whether I get bankrupt or not. But honestly, let's say we had a lot of discussions, and when we still owned Core Network Dynamics and we attended 5G ASEA in these early days, Siemens approached us and said, hey, will Core Network Dynamics provide factory networks, and will you really run it? We would be happy to see a new shooting star in this area. So the market is ready for this. So we have to wait a little bit. But in the end, in order to answer your question, there will be 3 options. There will be a very small, let's say there are big enterprises having their own IT infrastructure. They definitely will go for an own core network. Yeah? Because this own core network coming from whomever will be a very optimized network infrastructure for these specific use cases. Yeah? Low latency, maybe ahead of the standards. Network operators have to provide standardized equipment because of the overall rollout. So they will be behind the whole story. Then we have medium-sized enterprises where the question is, will they be able to run it on themselves, or will they outsource this business? When they outsource this, they might outsource to network operators, or there will be a new kind of enterprise network companies. And there are quite, these days, a lot of companies who are building networks for these special events. You know, if we have Soccer World Cup and we need connectivity on Brandenburg Gate area, these companies, one of them is called Smart Mobile Networks, is prepared to build local networks. Yeah? They do the Wi-Fi setup, and for them 5G is not a big different thing. So, and then there are very small enterprises, they have to get what is available.
Okay, so I know Thomas is in a hurry. Time for another question, or better?
One final.
Any other final question here, or everything is clear?
Do you have a business card?
Yeah.
Okay, then my question, you covered it a bit, but...
I'll drop an email and we stay in touch.
Okay.
Then I would say, thank you, gentlemen. Enjoy the day. Enjoy Berlin. So hopefully we see a little bit of more sun. And hope to see you in November. If you are in Berlin before, there's an open invitation to visit us and see the 5G playground.
Thank you, Thomas.
Bye-bye.
And again,